Okay, so we have graphed quadratic functions. Now we are going to move on to polynomial functions. So polynomial functions are anything that, well, you have a monomial. How many terms is in a monomial? One. And a polynomial is just anything, any group of terms, right? So quadratic would have at most 3 terms in it. But we will have a quartic. What degree do you think quartic is? 4. Cubic, which is 3. Quintic, 5. Usually after quartic, they just say 5th degree, 6th degree, 7th degree. Okay. So we are going to graph them and learn how to do that. Oh, of course my pen is dead.
We can try with your finger.
Yep, this could be fun. Maybe I can do this. Okay, so standard form of a polynomial. All like terms combined and all terms are written in degree of descending order. So I have negative 4x plus 9 plus 2x cubed. Is that in correct form? No. It should be 2. No, that's not going to work. That's not going to work. Should be 2x cubed minus 4x plus 9, shouldn't it? Leading coefficient. You do not have a leading coefficient until it is in standard form. So once you put it into standard form, the leading coefficient is the non-zero factor that is multiplied by the greatest power of x. So in our 2x cubed minus 4x plus 9, our leading coefficient is 2. You cannot have a leading coefficient until it is in standard form. If you tell me the leading coefficient before it's in standard form, you have the wrong leading coefficient. The degree of the polynomial is the highest degree of any of the terms.
Putting it in order.
What?
Or putting it in order.
Well, you need to know, like, what is the degree of this polynomial? Let's say.
Is it the third?
Yeah, the third. It's a third degree, so it's cubic. Okay. How many terms are in this polynomial?
3.
3. So you need to be able to put it in standard form, tell me the leading coefficient, all that kind of stuff. Okay, so what is each polynomial standard form? What is leading coefficient, the degree, and the number of terms? So I have 2x minus 3x to the 4th plus 6 minus 5x cubed. Put it in standard form. Someone want to help me out? Tell me what standard form is.
Y equals mx plus b.
No. Anyone else want to take a stab at that? Is it written in the right order, guys?
Oh, that 5 and the 6 need to switch?
Nope.
So, wouldn't it be, wait, for A, we have to write it in the right?
It needs to be in the right order.
No, it should be negative 5x cubed minus 3.
No.
Or no, negative 3x quartered.
To the 4th.
Oh.
Negative 3x to the 4th
Minus 5x cubed.
minus 5x cubed
Plus 2x plus 6.
plus 2x plus 6. That is in standard form. What is the leading coefficient?
4? Or no, never mind. That was a lie. Negative 3x.
Negative 3. What is the degree?
4.
Now, I will tell you, okay, when you're like in Algebra 1, when they give you the degree, they give you all these weird cases and everything else like that. Okay? Typically, how many variables do you have in one equation? One, right? But if you were to have more variables, okay, so if you have x and y, you of the leading coefficient, you add the degrees together. Okay, it's only if you have more than one variable, and that's not something that you tend to do. Well, you'll have them if you go into higher math, but they're not going to ask you for the degree of it. It's weird. Okay, so x to the fifth plus 2x to the sixth minus 3x to the fourth minus 8x plus 4x cubed. Write it in standard form.
Is that it?
What? On the first one, yes.
What if they have the same degree, like two numbers?
So if they have the same degree, then you should combine them, correct? Wouldn't they be like terms?
Oh,
So Cooper, what comes first on B?
2x to the sixth.
Okay. Next.
Me?
Yeah.
X to the fifth
So plus.
plus, x to the fifth. And negative minus 3x to the fourth. And plus 4x to the third. And minus 8x.
Okay. What is the leading coefficient? 2. What is the degree? 6. How many terms is in B? 5, right? Terms are terms are separated by addition subtraction. Yes? All review of like, what is the coefficient of x? Mm-hmm. The leading coefficient is 2. What is the coefficient of x?
1.
Look at it.
2.
Look at x.
-8.
-8. Thank you.
Oh.
What is the coefficient of x to the fifth? 1. What is a coefficient?
Number in front of the...
The number in front of the variable. Okay, so end behavior. I want to be very specific about this. Do not just start writing if you don't know what you're writing. End behavior of a polynomial function describes only what happens as x approaches infinity. So that means if I have a graph that only says what's happening here and what's happening here, it tells you nothing about what is happening all in here. The end behavior are the ends. Got it? Everyone clear on that? Okay, so if the degree is odd and positive, this first box, the degree is odd and positive, the graph will end going up. See all these going up? So we're going left to right, and it ends going it ends where? Going up. Now, if it is odd and it's ending going up, it had to start going what? Look at the picture. Down. So odd, positive. Odd, positive. Your end behavior ends up, so it started down. I've done the arrows for you before, correct? We did up, up, and down, down with quadratic. Well, is 2 odd? Is quadratic is 2, yes. Is 2 an odd number? No. So it didn't look like this, did it? So if it is even positive, then it is ends up and it started up. Think about it. Odd looks odd. Even looks even, it's symmetrical. Okay? So both of them ended going up, did they not?
What if they have a negative leading coefficient?
We're not even there. Not there yet. Don't give me what ifs. Okay, so when they're positive, they're going to end going up. It's where they start that's different. Odd, they start at the opposite end. Even, they start at the same. So we do this dance. Even positive, odd positive. Why is the second one an odd positive? Is it ending from left to right going up? So it had to start going where? Down. You will always see me put, if you tell me odd positive, I will put start ends up, so it started down. I always start about the end. Okay? So now, if it is odd, negative leading coefficient, so that means it's not going to end up, it's going to end what? Down, so it had to start up. So it ends down, so it had to start up. Again, I'm not talking about anything in between those two arrows, am I? Only the end and the beginning. So if it is even, I hate writing with my finger, negative, it's going to end down, but then it had to also do what? Start down. Because evens have to be symmetric. They have to be nice and even. They're just giving you different pictures on here. Okay? Showing you that in here doesn't matter. Doesn't tell me end behavior, tells me nothing about this stuff. It only tells me about the what? The ends. Now, technically, when you write these, hopefully my pencil will work now because my finger is not going to work for this. Technically, when you write these, you say, as x approaches negative infinity, that's this way, right? What are the y's doing? Where are they approaching? What is up? Positive infinity. Oops, that was a big one. Negative infinity. Y approaches positive infinity. And as x approaches positive infinity, what's y doing? As the x's go this way, what are the y's doing? Y's are approaching negative infinity. So you can write it like that if you want, but isn't it easier just to do this? That's the left and right hand behavior, isn't it? Okay. Questions, guys? Okay, so use the leading coefficient and the degree. It's called the leading coefficient test. Okay? So first of all, you have to ask yourself, is it in standard form? What's standard form mean again?
Yes, it is.
In the right order, right? Descending order. Okay? So, is it in standard form? Yes. I'm just going to ask you some questions. What is the LC? 2. What's LC mean?
Leading.
Okay. And what is the degree? 6. Okay. Now, A, which is the leading coefficient, is 2, right? So, this is positive and this is even. Yes? So it's positive, so it ends up. It's even, so it also had to start up. So again, I'll write it like the book would write it. As x approaches negative infinity, that's this one. Y is approaching where? Positive infinity. And as x is approaching positive infinity, that's the right-hand side. What's y doing? No, what's it doing? Positive, it's going up again. The other one was odd we did. Okay, so again, I'm okay with these arrows, but these arrows say the same thing.
Just make me check again for ID.
Those arrows say the same thing. Okay. So on B, is it in standard form? Okay. What is the LC?
Negative 5.
Degree is 3.
And the degree is
3.
3. So it is negative, odd. So that means it ends where? Down. So that means it started up because it's odd, right? And if I wrote it the long way, as x approaches negative infinity, oops, I forgot my approaches. Did you know that arrow means approaches? X approaches negative infinity. Y approaches what? Positive infinity. And as x approaches positive infinity, y approaches negative infinity. You need to be able to read those more than anything, because they'll write things like that once in a while. I just think you need, the whole purpose is to graph it, right? So if you can draw this right here, can you tell me which ways the ends go? Yes, Brandon.
Well, the x's, like how the x approaches negative infinity, then on the bottom x approaches positive infinity.
Mhm.
Will those always be the same?
Yes. You always talk about the left-hand side and then the right-hand side.
Okay.
Because when we graph, there's the x and y axis, right? We always talk about a graph from left to right, from negative to positive numbers. Other questions? Okay, so, okay. Says graph the polynomial function using the points. So we have an equation right here. Yes? Oops. It skipped. We have an equation right here. And it says on the interval from negative 2 to 0. So the first one is going to be negative 2 and the last one is going to be what? 0. So I have to get some points in between there, don't I? Okay. This might be fun. I always say you need 4 or 5 points. So we're going to identify the turning points, the relative minimum or max. So a min would be when it goes up. A min would be it goes down and then goes back up, right? And a max would be go up and go back, what? Down. Okay. And find the average rate of change over the interval of negative 2 to 0. And actually, we don't have to just do negative 2 and 0. We could do some other numbers. I want numbers that are going to be divisible by what? What fraction is 0.5?
What? Sorry?
What fraction is 0.5?
1/2?
1/2. So this is really negative 1/2 x to the 4th plus 3x squared plus 2. Yes? Okay. Actually, you're not going to have to do those, though. That's it? Okay, we're going to do this one instead. Sorry. Okay, we're going to sketch this graph. We're going to follow this information. And we're also going to state the domain and range when we're done. Okay? So it says f of x, so the function, is positive. What does positive mean? Where's it at if it's positive? Above or below the x-axis? Above. So it's above, right? From negative infinity, so over here, to where? Negative 4. So 1, 2, 3, 4. So this is negative 4. So from all of this up here, the graph's up here. Yes? I'm going to get rid of that. I'm going to put a big plus. I know it's plus over here. Okay? And then it says from negative 1 to 4. So here's negative 1. 1, 2, 3, 4. So it's positive up here. Right? It says it's negative from negative 4 to negative 1. So that'd be in between here. Wouldn't it? And then from 4 to positive infinity. So that would be over here. Okay. It is decreasing from negative infinity to negative 2.67. So that's like, so that means it's going down to like right here, right? Wouldn't that be like negative 2.67, like right here? So it's going down and then it has to go up, doesn't it? I hate to draw anything yet, but can we use this point? Can we just say that point?
Yeah.
Okay. And then it says it's decreasing again from 2 to positive infinity. So from 2, well, it's positive at 2, so we just make a point somewhere. How about there? Does that work? Okay. Unless it gives me an actual point later on. And then it's going to go down here. And this is going down till we get to this point. So then it's increasing from this negative 2.67 to where? 2? Doesn't give me any x-intercepts or anything, does it? No. But it kind of does because it says it's positive till negative 4. So wouldn't that mean that's probably an x-intercept? Yeah. And then it says from negative 1 to 4, it's positive. So these are probably x-intercepts also, aren't they? Yeah. Is that a good point? Did it tell me how far down it went? No. Did it tell me how far up it went? Could I put it like here if I wanted to?
Yeah.
Yeah. And now I'm going to draw a graph. So it says it's decreasing, so I gotta start up here, right? Hit it, then do what? Go back up to here, and then go back down to there.
I thought I was supposed to touch that point.
It did.
The one.
Oh, we changed it to the pink point.
Oh.
Okay, so we're gonna ask some questions. Domain. X such that, did I limit anywhere? Do you have any asymptotes or anything? So it'd be all real numbers, wouldn't it? So I can put all real numbers, or interval would be from negative infinity to positive infinity. This is set, right? This is interval. So watch what it asks for, set or interval. Okay, range. Well, if it goes to infinity there and to infinity there, so it's also what? All real numbers. Okay, where's the minimum? No, minimum would be down.
The negative 2.67.
The negative 2.67, and we made it at what, negative 2? It didn't tell us, but we just made it there, right? Where's the maximum at?
The one up there.
2.
2,
5.
5, is that where I put it? Yep. Okay. What's the degree of this? Do you know the degree? From the shape of this, can you tell me the degree?
W. I could.
Odd negative.
It's going to be an odd negative. He didn't say what odd number, did he? But is it going to be an odd negative? How'd you know, Cooper?
But it starts down and goes up.
I mean, starts up, goes down.
It's not the same thing.
No.
What I heard.
Because up here, negative infinity would be positive. Positive infinity would be negative. So we know it's odd and negative, don't we? Because if it's negative, it's ending down. Is it ending going down? Yes. And it's starting going up. So this is like this. So that would be an odd negative. But I don't know what odd one is it. But maybe I do. So this goes once, it changes, yes? And then twice. Okay? It's at least I'm going to say that wrong.
What is making that sound? Oh.
3.
How do you know that?
Actually, it's not at least 3, it's 3.
How do you know that?
Because, how about I spell degree with a D? You have exactly n minus 1 turning points. So if the degree is 5, what's 5 minus 1? 4. So the graph is going to turn how many times? 4. So this turned once and twice. So the degree is 3. Now you have exactly 3 zeros also. Those are x-intercepts, yes? But did I say real zeros? No. You have exactly 3 zeros, but some of them could be imaginary. Like this could go something like that or something weird. Okay. I'm just trying to think what else. So today we're gonna look at things, and you're gonna tell me the degree and all that kind of stuff, and you're gonna look at a graph, and you're gonna tell me the domain and range. Now the range and domain would look differently if I were to stop it, right? So let's stop it. I'm gonna erase this to here, and I'm gonna put this to here. So let's think about this again. So domain are x values, yes? Okay. So the domain of this graph is from what to what? What is the smallest x?
-4.
-5. What's the biggest x?
5.
4. Now, those are greater than and equal to, yes? Because they're closed. What if I made it like this? Would it be equal to then? Nope. We'll leave it like that. Okay, that is in set notation. How am I going to write this in interval notation? What's the smallest? -5. And it's included, so we put a bracket, comma. What's the biggest? 4. Is it included?
Yeah.
No. I got a big old hole right here. Nope. So I put a parenthesis. What is the range? What's the smallest y?
-3. -2.
-2. What's the biggest y? 5. Is 5 included?
No.
Nope. If there's no dot, then it's included, right? Like over here, there's no. And if I'm going to write that, it'd be -2 bracket, comma, 5. Okay. So that's what your IXLs are today. That's it. Very basic. They will be very quick.
How many?
There's 2, and they're assigned in classroom.